Hi, good morning and good afternoon, everyone. Thank you for joining us today for this last webinar of the year, at least for us here at Cyber9s. It's good for you to, it's good of you to join us today. My name is Jean-Jérôme and I'm with the Cyber9s team, and I'll be looking after you from a hosting perspective for the next 60, 75 minutes or so. The session is planned for a little longer than usual, so it's the presentation itself will take about an hour. And we'll have time also for for questions and answers. If you do have questions, during the course of this webinar, feel free to ask them by using the question section of your control panel, and we'll be happy to answer them at the end of the webinar. And if you want to continue the conversation or have some other questions, feel free to email me at jj@cyber9s.com. You have the link here on your screen. And we'll be happy to continue the discussion with you via email as well. But for now, we're live, and just to give you a quick introduction on Cyber9s and our product cluster control before we get started with today's topic. What we do, we specialize in automation and management of open source databases. So that goes from deployment to monitoring, through to management and scaling of open source databases, and our product to achieve those things is called cluster control, of which you can see some of the main features elements here on your screen, from provisioning to monitoring and management. It's a very complete product that offers capabilities for fully managing and automating open source databases. We support the following databases, all of the different MySQL flavors, MongoDB, in the MongoDB version, but also the Percona flavor, and then we also support PostgreSQL. We have over 8,000 customers and users to date, some of which you can see here on your screen, between telecommunications, public sector, entertainment, and so on. Different types of companies use cluster control to automate and manage their databases with us. So that's to give you a quick overview of who we are and what we do. And today's topic is all around tips for going in production with MySQL Replication. My colleague Christoph is going to present today. And before I hand over to Christoph, I wanted to ask all of you a quick question. And that's really to set the scene for the next 60 minutes or so, or help us set the scene, and to ask you what MySQL setup you're currently using yourselves in your work, or maybe even on a personal level, whether it's standalone MySQL or MariaDB. Maybe you're using Galera cluster, MySQL NDB cluster, of course, and replication cluster, which is today's topic, or some other setup. It's a multiple answer question, so of course you may have different setups that you're looking after. So it'd be great to get your feedback here. I let this run for a few seconds, and just as a reminder that you can ask questions at any moment, of course, by using the question section of your control panel. If you see anything in today's content that you're not quite clear on, that you'd like some more details on, feel free to ask your questions at any point. And we'll get to them towards the end of this session. But for now, thanks for your participation in this poll. I'm just going to close this now and share the results. Great. So interesting. It's not too unlike. So we had this topic earlier today. For people in Europe for their morning time. Standalone MySQL MariaDB seem to be quite popular there. We didn't have any NDB cluster this morning, so interesting, nice to see some of you using an NDB cluster, and then it's a split between Galera and replication cluster. Christoph, any comments on this before you start with your presentation?
Yeah, I mean, that's basically the target audience that we intended for this type of webinar. I really hope that all of you that are not using yet replication in the production will pick up some interesting tips and suggestions on how to good practices on how to run the replication environment. And for those who already have some experience with MySQL Replication, I still hope that you'll find this interesting. Yeah, you will basically again pick up some hints, pick up some tips on how to make your environment better, or make it the replication more smooth. So yeah, I hope that you will enjoy this one.
Great, thanks, Christoph. And I'm just going to close this now and hand over to you.
Okay, thank you, JJ. So good morning, good afternoon, everyone. As JJ said, my name is Krzysztof Książek, and today we would like to talk a little bit about MySQL replication in production, some tips and hints on how to what is important when dealing with MySQL replication in production, what is important when you think about moving into MySQL replication, switching to this setup. We have like 9 points in the agenda, 9 pretty important stages, like topics that we would like to cover. First of all, we will talk about some checks, some sanity checks, some things that you should be aware of before you actually migrate into MySQL replication. Some things that you have to make sure that you cover, that you're aware of them, that you think them through, and before you actually start setting up the replication setup. Then we will cover a little bit of operating system configuration. And we will talk about the replication itself, some hints about how to configure it, some things to keep in mind. Backup solutions for MySQL replication and MySQL in general. Provisioning, so how to provision Slave, how to build your replication cluster. Some tips regarding performance, proxy caching layer, what you should plan for, how you can try to, what you want to build, what tools that you can use to build a scalable replication setup. Schema changes, which is pretty important topic for like every MySQL setup, but especially also for MySQL replication. Reporting, some analytical queries, how to deal with them with replication in replication setups, and finally disaster recovery. So how to plan for the worst, how to survive like complete fallout. Let's start with those checks, the sanity checks that you should perform, that you should understand, and that you should think through before actually migrating into MySQL replication setup. First and foremost, use InnoDB. So the problem with MyISAM is that it will basically break, and actually MyISAM and any other non-transactional engine, like memory also, for example. It will break data consistency when query gets killed. So what happens? Like you run some kind of query and the query gets killed because like this query sniper, or maybe you just some developer just stop the query, or some kind of timeout, or maybe even the master just goes down. Yes. So the query won't be replicated because the killed query will not be replicated, and the query which like died, if master dies when the query is executed, the query of course will also not be replicated. But if you are talking about non-transactional storage, some changes are already made, and you already have data drift inconsistency between master and slaves. So if there's no rollback support, then every crash of the master is basically equals some sort of inconsistency. Every query that gets killed equals some sort of inconsistency. Therefore, InnoDB is the way to go. Primary keys. Well, obviously, you define them on every table. So first of all, that's important for InnoDB because it speeds up the InnoDB operations. But it's also a requirement for tools like PT Online Schema Change, which are crucial when it comes to dealing with schema changes in MySQL replication. And we'll be talking about it later on today. But this is very, very critical that you have all tables, covered with the primary keys. When in doubt, if you don't know how to or on which column to create a primary key, just create a new column, like use auto-incremented unsigned integer and create a primary key out of on this column. That will be just fine, and this will work okay for you, and that's basically the way to go. You should embrace lag, replication lag, as something inevitable. That's basically an element of working with MySQL replication. Lag will hit you, lag will show up. You will be dealing with replication lag. So you just have to embrace it. But what is more important, you have to be aware of your application requirements, because you have to answer the question, like, what is an acceptable replication lag for you? Like, what is the acceptable replication lag for application? Maybe some of the blocks, some of the modules, like or parts of your application can work with some relaxed requirements. Maybe it's just fine to have like data start for like a minute or 5 minutes. But maybe there are some parts of the applications that are required the data to be up to date all the time, and then you have to understand this, and like it will basically impact how you route your traffic, because maybe you will have to route some of the selects to master every time, because that's the only way you can be 100% sure that you get the up to date data. You have to understand your write patterns, because obviously lag is mostly created by a huge number of writes. Maybe you do some sort of batch loading, right? Or maybe you do some heavy writes. This will create lag, so you have to know when this happens. You need to know what you can do about this to minimize the lag. Maybe you can reschedule this kind of processes or something like that. You also have to understand your read patterns. So like heavy reading also can impact the replication lag, because like heavy reads, like if you start to read a lot of data, like for some sort of analytics or something like that, such reads can basically remove data from buffer pool, right? Because they would just evict old, for example, dirty pages from the buffer pool. And removing dirty pages, flushing dirty pages out of the buffer pool requires I/O. I/O can, if you're running, if your hardware is somewhat a bottleneck, additional I/O can basically result in in a replication lag. And this on the screen, you can see the section of the custom control called Developer Studio, in which you can write JavaScript-like scripts programs. And we have some examples that you can, for example, the scripts are existing that can be used, for example, to check for MyISOM tables, to check for tables without primary keys. What is important is that you automate these tasks, because you never know when a developer will create some sort of table without primary key, or force the table to become non-transactional. So it's important that you have some tool in place to monitor those your schema, and to track this type of problematic patterns. Operating system configuration. So this is mostly similar to other MySQL setups out there, but still would like to go through some of the good practices here. First of all, ensure that you have swap enabled. There are different approaches. Some people assume that it's better not to swap, but personally I would rather want to see MySQL slowing down than to get killed because of the out of memory, or the whole system hangs out because of the out of memory. what you can try to do is to reduce the priority for OM killer for the MySQL process ID. But this is not really like 100% solution, because usually it's MySQL which is using the most of the data, most of the memory on the system. So it is quite possible that there will be no other processes to kill. So the system will hang anyway. So ensure that you have swap enabled. But even though, make sure that you reduce swappiness to minimum. So basically set it to 1. This will ensure that the swap will be used only like if there's there's no other way to go around. But normally during normal operations, swap won't be used. If you're working using NUMA compatible hardware, make sure that you use NUMA interleave, so that the memory used by allocated by MySQL is evenly split across the NUMA banks. Right now, if you're using recent MySQL version, most of the time it's already done, either in MySQL configuration or in init scripts. But just verify that it is indeed the case in your system, and that's set correctly. Use, the file systems of choice is either ext, for, or xfs. Exact choice, it really depends on the kernel, on the operating system, or the file system driver that you have, because it's like it's a never-ending story. Like at some point in the time, ext4 was better than xfs, and again ext4. So everything depends on your particular setup. Usually the difference is very minimal, but if you're interested to squeeze, the most of your system, just run some benchmarks and see which file system will work better for your particular case. There's no need to maintain metadata, file system metadata on the MySQL data directory. So if you're mounting file system for MySQL, just use no time and no add time. That's no need for that. If you're running in a virtualized environment, keep an eye on the CPU steal, because that's like this can tell you that either you are allocating your resources, like you're just trying to squeeze too much out of your VM, or it's the host which is like over provisioned, and your VM is not getting the resources it should have. So that's something which you want to track and then react accordingly if needed. When running with VMs, it's also important to keep in mind that VM snapshots may impact databases. Basically, it's some sort of stall for like a couple seconds, 2, sometimes more. It is not that big deal when if you're talking about MySQL replication. It's much more problematic when we're talking about clusters like Galera cluster or MySQL cluster. But still, just be aware that this may happen, and some weird behavior can be a result of for example, VM snapshot. Replication. So first of all, we have to decide what type of which form of replication we are going to use. Statement replication is basically out of question because of it doesn't maintain consistency between master and slaves. So personally, for me, role-based replication is the way to go. That's the only method that will it will ensure data consistency. Like a mixed-based replication, mixed format should also maintain the consistency, but The thing is that the problems will happen, yes, anyway. So like it's either something which is related to slave or during some maintenance something went wrong, so the inconsistency will appear. The difference between the mixed format and role-based replication is the fact that role-based replication will be impacted by the inconsistency earlier. And that's actually a good thing, because you'd rather have your replication broken and know that something is not right, and then you can act and rebuild slaves, for example, then leave not knowing that slave is drifting away from the master, because the statement type of statement replication, or the statement part of mixed format is going through, and everything seems to be okay while it's not. So definitely I prefer to be alerted by some sort of monitoring tool that my replication is broken because of inconsistency, because then I know something's wrong. Of course, this is not enough, like just waiting for something to happen. You want to act proactively to maintain consistency under control. For example, you can use tool from the Picona toolkit called PT-table checksum, which is intended basically to compare contents of a table on a master and slave. So basically it just goes to the table, and if there is some sort of inconsistency, it will be reported. So run this tool in regular intervals, and make sure that all slaves are in sync. And if they are not, then it's time to fix the problem. And to fix the problem, you can try to use another tool from Picona toolkit, PT-table sync. And that's actually, this tool is designed to, it can work separately, but it also can work on the data created by the PT-table checksum. And what it does, it just checks what type of inconsistency is between master and slaves. And basically it creates a list of SQL that is then executed on the master, and which is intended to bring the slave back to sync. This should work most of the time, not always. Sometimes the inconsistency is so great that it is pointless to use this tool. It will take just too long to fix. In that case, in the worst case scenario, basically rebuild the slave using the data from the master, or from another slave that you are sure that you confirm that is in sync with the master. And it's very important that you don't be afraid of that, because for the more complex problems, that's definitely the easiest, the fastest way to bring slave back in sync with the master. Automated failover. So this is very important decision that you will have to make, whether you want to perform an automated failover when something goes wrong with replication, or if you prefer to leave it up to the user, the administrator, DBA, to make such call. There are tools which can perform the automated failover for you, among others, the cluster control, but also, for example, MAJ. So it is up to you to check, to decide if you're going with automated failover or not. Another thing is GTID, Global Transaction ID. As long as you can use it, use it. That's everyone has some other take on that, but that's my personal opinion. GTID gives you a great deal of flexibility in how you can change your application topology, in how you can react when master goes down. So instead of finding binary log positions and making some black magic from the past, you can just run change master to master host, master user, master password, master auto position equal to 1, and you're all set. Of course, you can also do the same for MariaDB with the equivalent command. What is important that you check for error transactions before you switch to the master. Switch the master, like failover or switch over. An error transaction is a transaction which has been executed on the slave but hasn't been executed on the master. So it's not coming from the master, it was just created on the slave at some point. And that's a problem because such transaction, it can break the data consistency. I mean, of course, like having some writes on the slave breaks the consistency, but it can also break the replication. And it happens because if such error transaction happened like a long time in the past, then it's no more in binary logs. Like it was binary log that contained this transaction was removed. And then if such slave at some point in the future becomes a master for some reason, other hosts connecting to it, trying to slave of it, will ask for this particular transaction because they will ask for any missing transactions. And as such transaction does not exist in binary logs anymore, the replication will break. So you have to check for that. You have to track for that. There are tools, there are commands in MySQL to compare GTID sets. So you have to keep it in mind. And picking up the tool, you also have to that performs automated failover for you. You also have to make sure that it handles error transactions, or at least stops the failover if the transaction is a problem. If possible, try to use benefit from multi-threaded replication. So basically, in MySQL 5.6, schema-based multi-threading was introduced, which means that if you have a couple of schemas and you write multiple schemas at once, slave can basically paralyze those writes to some extent. In 5.7, logical clock-based multi-threading was introduced, and now parallelization can happen also between writes hitting the same schema. It is also important to keep in mind that if you want to use multi-threaded replication, it goes always with GTID. Technically, it's not enforced. So technically, you can run multi-threaded replication without GTID. But this is just a simple way to run into problems. Because the problem with the multi-threaded replication is that every thread can end up at different position, binary log position. So there is no one single position that you can point a slave to, and it will just work. While when running with GTIDs, you just have a list of transactions which have been applied or not. So that's a very simple way to check what's missing and execute those transactions. And as I said, the multi-threaded replication is a great way to speed up the replication and to reduce the lag to some extent, at least. Backups. So there are two types of backups, like logical backup and physical backup. Logical backup is basically data stored in plain text, like be it SQL form, SQL queries, or command separate value, or some sort of similar text format. It gives you easy way of modifying stored data, right? So you just edit a raw entry in the text file, and yeah, you're all set. It also gives you some easy way of restoring single rows, right? Just find a row that you want to restore, then copy paste it to some separate file and either execute SQL or just run load data in file, and again you're all set. So I mean, it is important just to keep in mind that you have to benefit from that. You just have to keep those log files small, like as small as possible, feasibly as it's feasible. But that's because otherwise it will be just hard to work with such large files. On the other hand, physical backup, data is stored in some sort of binary form. So tools that you can use is extra backup, some sort of snapshot like EBS snapshot in Amazon, or LVM snapshot or Sun snapshot. It can be also rsync, SCP, or even CP if you just copy your data on some other partition. Physical backups are great to restore whole data at once, right? Because you just copy things. They're not so great to restore subset of data. So then there are some exceptions, like extra backup, for example, allow to restore table spaces and schemas. But there's still no way to restore single row. And even though you can restore table spaces and schemas, you cannot use it to restore a host and make it like consistent replication wise, because that's it won't work like that. So you can just do it to restore some standalone host and then dump the data out of it and load into the replication cluster. MySQL dump, I mean, probably it's the best known backup tool for MySQL. Can dump tables, it can dump schemas, it can recover even a single row, which makes easier if you use extended insert equal to 0, which will basically disable the extended insert and ensure that every row is using like separate insert. It can cause some locking, but it's not that big problem if you use InnoDB, because you basically can use a transaction as a way of taking a snapshot of the data. MySQL dump can generate large SQL files. So as I said, this could be a problem. So you should just dump separate tables, right? And not full schema at once. Because basically it's easier to manage and to edit and to restore like 100 files, 1 gigabyte each, than to edit something in one file with the size of 100 gigabytes. That's just much more easier. MySQL dump can be used to be the slave using master data flag. That's a pretty long, inconvenient way of doing that because of the very long recovery time. Because MySQL dump needs to parse. I mean, when the data dumped using MySQL dump, it needs to be loaded. Then basically MySQL has to parse all those inserts, and this takes time and adds some overhead. MySQL dump also is single-threaded, so technically you can try to run it in parallel on a per table basis. So it is possible to parallelize it somewhat, but depends on the table size, and it's just not. It requires some additional scripting. Also, if you are using some non-Latin characters, then this character set handling can be tricky. But that's, it gets better with UTF, but still, this could become a problem at some point. So MyDumper, MyLoader. So basically that's MySQL dump, just slightly different and better. The most important feature is that it allows parallelization within a table, because the table is split in chunks, and those chunks can be restored in parallel, can be dumped in parallel. In past, it was a very annoying tool, which was hard to compile, hard to build, hard to use. It's been improved significantly over the last year. I believe, if I remember correctly, Percona took kind of an ownership of that. So the support for dumping schema has been added. In the past, it was not possible. You had to use MySQL dump for that. Right now, it's so much easier to compile it from GitHub repo. To just copy paste instructions, and it actually really works compared to what happened in the past when you just had to particular type of compiler on a particular type of distribution to actually do something. Binary packages are also available, even by default in distribution repositories, but they're not always up to date. As I said, it's not that big problem because it's very easy to compile those tools from the source code. Pretty nice dump time. Of course, your mileage may vary because of the data type, hardware, and whatnot. But 1 terabyte of data in for 6 hours, that's really nice when it comes to the logical backup. My loader still has long loading time, even if you use some sort of parization. But again, it's not as long as when you load the data created by MySQL dump. So if you needed to use some sort of logical backup, that's the basically fastest logical backup that I know. So you can take a look at it if you decide that you want to use this type of backup. Extra backup, that's physical backup, and that's I would say the backup solution for MySQL. Only backup for the DB tables. It's like almost non-locking. How it works is just copy the data files, the table spaces, and at the same time it parses the transactional logs, read the logs, and logs the transactions which are happening in the meantime. So if you have MyISAM, you will get locked. So just don't have MyISAM, don't use it. There's no really need for that anymore. Extra backup supports local backup, supports streaming over the network, supports incremental backups, support compression, parallelization, I believe even encryption. I'm not entirely sure about that, but you can just definitely bundle with other tools that create very nice backup flow. Basically, do whatever you want. So the backups created using extra backup needs to be prepared. Basically, the transactions from that log which were collected in the background, they have to be applied. When applying logs, keep in mind that there is use memory flag, which can speed the process significantly. Extra backup supports partial backups, as I said, so per schema and per table. It comes handy when restoring missing data because it speeds things up because you can restore just a single table, not the whole data set. But as I said, it's not, you cannot use it to create a consistent slave. So you just have to do it on separate hosts and then dump the data, and then using logical, like extra backup, MySQL dump or MyDumper, and then load this data on the replication cluster. And it was very important, but it can bundle replication information with the backup. So you can easily use extra backup to create new slaves to provision new hosts in the replication topology. So a couple of words about best practices when it comes to backups. First of all, ensure that you have some sort of backup policy defined. So you have to answer a couple of very important questions. How you want to back up your data? Do you want to have both logical and physical backup, or maybe one of them? What types of backup are available for you? If you're running on Amazon, maybe you have access to EBS snapshots. or otherwise, maybe you use LVM or not, or maybe you have some sort of hardware which supports snapshots, right? Volume snapshots. Then, how often do you want to back up your data? That's also very important. Like on a weekly basis, on a daily basis, couple of times per day, couple of times per hour. It also will define what you can do, right, with your backups, and what tools you can use. Like if you want to back up your data a couple of times per hour, then most likely you will have to do some sort of incremental backup using extra backup, because other way you can just end up with some. If the backup itself takes more than an hour, you can just run it a couple of times per, which is pretty obvious. How long do you want to store the backup? This will define the hardware requirements for you to. How large you want to have. You need to have some disk space to accommodate your backups. Do you need point-in-time recovery? Most likely you do. In that case, you also, in addition to regular backup, you also need to backup binary logs. So that's basically, you have a couple of questions you have to come with some answers, and which will tell you put some boundaries between you can build your backup solution. Pretty important, make sure that you copy backup offsite, yes, for some sort of disaster recovery. This is basically a requirement, because otherwise, something may happen to your data center, and all of your data is lost. It can be separate data center. It can be S3 in Amazon. It's up to you, but you want to have some sort of offsite backup. Of course, backups will cause some impact on MySQL host, right? There's additional CPU and additional I/O load on the system. Some logging may happen also. Therefore, you may not want to use it on the master, nor you may not want to use it on the slave, which is used in by the application for some quick queries, like OLTP type of queries. Therefore, what you can do is basically create a dedicated slave for backup, right? A slave which is be used for backups and some other maybe processes which can accept some sort of additional load from time to time. Of course, the concept of Schrodinger's backup is very important. So every backup may or may not be good unless you test it. So basically, you cannot be sure if your backup solution works before you actually verify the backup, and you have to test the backups on a regular basis before you actually assume that. You can't assume. You just have to verify that your backups work. And here we have a couple of example screenshots from cluster control where with the backup management. So we can create ad hoc backup using different backup methods like extra backup, full incremental, or MySQL dump. You can also use some compression, use parallel zip, and different extreme and stream some data and throttle it. We also support scheduling backups, every day or a couple of times per day. So you can create a backup schedule, and then cluster control will execute those backups for you. And if you don't use, extra backup, if you don't use cluster control, the whole point is that you want to have this process automated. So if you don't use a ready solution that is can do it for you, you have to come together with your own scripts that will do the same. Create some scripts that will run backups and then run them from cron or something like that. But you want to have this automated. Ideally, you also want to have automated recovery tests, but that's like a next step. Provisioning. So you will be provisioning slaves often and for various reasons. So I mean, you'll be adding a new host to the cluster, so new slave. So you need to provision it. You'll find there's some data inconsistency on the slave, so you need to rebuild it. Hardware upgrade, so you'll be introducing new hardware or this new host on a faster hardware to your system, to your environment. And again, to provision it, you'll be testing different things like different queries or different processes or something like that. So you will be provisioning slave to run those tests on. Therefore, it is very critical to build some sort of provisioning system that will be easy, make it easy to rebuild and to create new slave. Because, as I said, you'll be doing it very often. What you can try to do is to leverage one of existing backup solutions. Like you don't have to, take grab the data out of existing slave every time. If you run, let's say, a couple extra backup, like a couple of times per day, then it may be enough just to grab the data from the latest backup and then provision a slave using it, and then let it catch up with the replication. So this could be a nice addition to your provisioning system. Of course, cluster control helps you to do point and click provisioning and scaling of your cluster. So yeah, it can do for you, but it doesn't have to be cluster control. It can be like Ansible, Puppet, Chef, recipes, modules, playbooks, whatever. But you just have to have some sort of automated setup for like tools to handle this process. And before we go further and talk about performance, I'll hand over to JJ for the second poll of the day.
Yeah, great. Thanks, Christoph. Yeah, and the question we want to ask all of you now, to take a quick break from the presentation, is on which proxies you currently use yourselves within your environment, which is between HA proxy, which is probably one of the most popular ones out there, especially for MySQL users, proxy SQL, which is a bit new, a new player, MaxScale from MariaDB, or maybe you're using hardware load balancers or some other, another type of proxy. It'd be great to get your feedback here. And just a reminder also that you can, of course, ask questions at any moment during this webinar by using the questions section of your control panel. So if there's anything that you're hearing about that you'd like to get more information on or some more precisions, then feel free to ask those questions by using the question section of your control panel. And we'll get to those towards the end of the webinar. But for now, thanks for your participation in this poll. I'm going to close this now and share the results. Right. So not too surprisingly, the vast majority of you seem to be using HAProxy, which makes sense. I think it's the most popular one for in the MySQL user world. What's a bit surprising, maybe it's the hardware load balancer. We didn't have such a high number on that earlier today for the first session of this webinar. Any comments on this from your side, Christoph, before you continue?
Yeah, as you said, the HAProxy is definitely the most popular tool, the proxy out there. It's nice to see both proxy SQL and MaxScale going up in numbers. Hardware load balancer, yeah, that's still a very popular solution. The problem is that, I mean, with hardware load balancer is that it's not as smart as you can make software proxies when it comes to managing MySQL topologies and handle any different type of failures. But yeah, well, that's actually nice to see that, like HAProxy, proxy SQL, and MaxScale, which are tools supported by cluster control. There are really nice and high numbers here.
Great, yeah, absolutely. Thanks, Christoph, and thanks everyone for your participation here. I'll hide the results now and hand back over to you, Christoph.
Okay, thanks, JJ. So the performance. So when we are working with MySQL replication, you have to keep in mind that performance of a slave may impact replication lag. Obviously, heavy writes will cause lag, right? Because that's what lag is all about: the high number of writes which replication thread cannot cope with. But there are a couple of things that you can do to minimize the problem. So first of all, you can split writes. What I mean here is let's imagine that you run some sort of heavy update or heavy delete on a column, on a table, and just like a couple of unions, like plenty of work conditions in workflows, and at the end you just delete or update, let's say like 2 millions or 10 millions of rows in a table. So instead of running one single query which will like modify millions of rows, what you can do is handle the logic on the application side, or just handle the logic in terms of a select, and then come up with a primary key based list of rows that you want to remove or update. So instead of running one query modifying 1 million rows, run 1 million queries, which and every single of them is accessing one single row using primary key. This will split things definitely much better than running one heavy DML. It's also important that if you have like 1 million queries, very simple queries, you can distribute them in time. So for example, you can implement some sort of throttling mechanism, which will be replication aware. And for example, if the lag becomes to show up, then you can, for example, stop the process, or you can slow down the process because you have the control, like you have those millions of queries, so you can stop at some point and then speed up and then slow down depending on the resources available. Also, you want to parallelize writes. Yeah? So you want to run the process multi-threading in multi-threaded mode. So you can leverage better replication throughput through the multi-threaded replication. What is also important, you have to monitor the system's performance. So there are different tools of monitoring and trending tools like Cacti, Grafana, PMM, Vivid Cortex, Cluster Control, which can help you, to give insight into database internals. It's just important that you pick whatever suits you most and then just use it. And here we have example graph from the cluster control regarding the query performance, and another showing us the replication lag in the cluster. So there is no efficient, highly available, performant solution environment without caching layer and proxy layer. So for the caching layer, just like use it, like Redis, Memcached, Couchbase. These are the tools which can be used here. Also, some of the proxies, like for example, ProxySQL supports caching, so you can kind of combine proxy and caching layer in one tool. So basically, the good caching layer can reduce database load in more than 99% even. And we want that, like we want to serve traffic from cache and just seldomly connect to the backend, the MySQL, and run some queries. Caching layer can also help to hide some issues of the database tier from the application, yes, because maybe there are some problems with the databases, but you can still handle the requests from the caching layer, and the application is basically not aware of the issues that are happening in the backend. What is important is to make sure that you handle cache refreshing properly. So we don't want just, if the cache expires, for example, you don't want to run like thousands of queries to the databases because it will just kill them, obviously. Instead, what you want is just run one single, like, if you run a query, like if you detect there is just, the data is shouldn't be expired, just do not expire it just now. You just run one single query to the backend to refresh the cache, right? And in the meantime, other application connections to the caching layer can wait for the cache to be refreshed from this one single query. So the proxy layer, as I said, just use it. It gives you proxies, especially the SQL Hour proxies like Proxy SQL or MySQL, but also to some extent AJ proxy can give you great flexibility and control over the database, and how to. They can detect failed nodes. They can make those topology changes. I mean, they can detect topology changes. They can react based on what sort of different logic that you can implement within them. And some of them, like for example, Proxy SQL can use connection multiplexing, basically to reduce the number of direct connections to MySQL. So instead of having for example, if application opens like 1,000 connections to MySQL, I mean, instead you can open 1,000 connections to the Proxy SQL, and the Proxy SQL will open, let's say, 100 connections to the backend, and use them as a pool of connections to handle any incoming requests. So definitely proxies can help you to work with MySQL Replication. Also, read-write split, for example, that's also very, very important. And as I said, basically, like we support all of them, like the most popular ones, AJ proxy, MaxScan, Proxy SQL, can be deployed through the cluster control. Schema changes. So that's pretty important topic in MySQL Replication. And there are a couple of changes, especially when comparing with standalone MySQL instances. So basically, in replication environment, any DDL equals to lack. So basically, when you have a standalone MySQL instance, there is this concept of online DDLs, right? So some of the schema changes are not impacting, like they are not locking writes or reads on the MySQL instance. Of course, there is impact in terms of the performance, but the writes or reads queries are not affected in terms of locking. And that's true for the replication also, but it's true only for the master. Because once such a DDL is executed and is replicated down the chain, on slaves it will be serialized. And that's also true even if you are using multi-threaded replication. In the future, this may change because Oracle works towards making DDLs transactional. But for now, that's how it is. Therefore, unless table is very small, direct DDL is basically not possible, not usable for in the replication topology. What you can do instead is to use running schema upgrade. So what you can, by that I mean that you implement schema change on all slaves first, and then on the master. So what's important, you have to make sure that schema change is compatible. And in short, that's a change. A schema change will allow application to work. And then the problem is that row-based replication is very strict when it comes to what is compatible and what is not. For example, adding a column at the end of the table is fine. Adding a column in the middle or at the beginning of the table, this will break the replication. Changing the column type from varchar to integer will break the replication, even if you use this varchar column to store integer type of data. And that's another problem with mixed-based replication, because it makes it really tricky. Because on the one hand, you can be like, most of the time you're using statements, which are much less relaxed restrictions. And they allow for more type of schema changes. But then you have to be exactly aware of what type of tables are involved in a role-based replication defense. Because if the query is determined as, if query is detected as non-deterministic, then this query will be written in a role-based format. And if the table is, if you have such queries, and you make an alter on such table involving those queries, you can basically break the replication. A list of changes which are compatible is listed in MySQL documentation, so you can consult it. But what's even more important, you just have to test your changes in staging environment all the time. And then you can figure it out if the change is safe or not for your particular setup. Instead of running schema change, you can use online schema change tools. So, for example, PD online schema change for Percona. Facebook also has their own online schema change tool, and their new recent addition is Ghost from GitHub. So those tools allow non-compatible schema changes to be executed because the change happens at the exact point of time through the whole replication topology. They are usually slower than direct DDLs, or so what is important that you test them on the staging host to assess time needed to accomplish the change. Python schema change is a well-known and tested solution. We know, all its pros and cons, strong points and weaknesses. What it does is just you use triggers to keep up with changes. So it creates temporary table and then creates triggers to mirror the changes to original table into this temporary table. And it also uses priority inserts to copy data between new and old and new table. One of the problems is that it requires metadata logs to create triggers, and for high concurrent workload, or for databases with long transactions, this could be a serious problem. And I've seen such environments when running Python schema change was literally not possible because of this issue. Foreign keys can also be a problem to tackle because there are two methods of handling them in Python schema change, and neither is good. First basically requires, first is dangerous because there is no rollback in case something goes wrong when you are switching old and new table. And other require a direct DDL at some point. So that's also a serious problem in replication. Ghost is a new tool and not yet widely used. And actually, Ghost is a tool which works only with MySQL replication so far. Galera is not supported. So what's important, you test it before you apply in production. It supports multiple test modes. It's possible to do a dry run. It is possible to use a test on replica flag to basically check the contents of old and new table on a stop slave. So basically, you're running on some of the slave, probably a new one which you just provision. The slave will have a replication stopped, and there will be all the new tables available, so we can just go row by row and compare them if needed to verify the tool did its job correctly. Ghost allows you to throttle replication if black is too big. So Python schema change can do it also, but there is one very important difference. Ghost doesn't use triggers; it uses blogs. So it parses binary logs for events and uses those events to keep the new tables in sync. And that's basically makes possible to actually stop the whole schema change activity. Because what Python schema change can do is to stop the background inserts. Triggers are still there, and triggers are still mirroring the writes to the table that you alter. While Ghost can basically stop the activity completely, like no zero null impact on the system. Ghost requires role-based replication on host where binary logs are scanned, and by default, to minimize the impact on master, it scans binary logs on the slave and then executes changes, obviously, at the master. Reporting. So online analytical process can be heavy on the database because CPU and IOIs, they can use some serious amount of resources, and this can make hard for application to keep up. Therefore, as a good practice, is to define some slave or create a dedicated slave for reporting and direct all analytic type of traffic into the slave. So basically, if you use a backup slave, there is also, you can use it also for this type of tasks. There's no, if those two processes can work together, and there is no need to separate hosts for that. The analytical processes can also execute writes, and of course, those can also become a source of load and replication lag. So it's important that you monitor the impact, monitor these processes, and build them in a way that they can be throttled and paused if needed, for example. So that's pretty. In general, any type of process that you're building, you should build with the lag in mind, with the replication in mind, that you can track the replication, track the lag, and throttle if needed, or pause if needed. This will make things so much easier for you. And then disaster recovery. So disaster will happen, and this is inevitable. So what you need to do is basically plan for disaster and learn to live with the thought that something at some point they will go completely crazy. And there are different ways you can minimize the impact, right? And then you have to just pick whatever works best for you. Obviously, you have to have a backup, because that's the foundation of the disaster recovery. And as I said, as I mentioned Schrodinger backups, you have to test your backups and store them outside of the data center, like a couple of them at least. The backups, they're great safety measures, but they can be slow to restore. Like if you have a large data set, it will take time to restore it. So if you need to have your systems up quickly, then you need to first of all verify how long it takes to restore your backup, and then try to figure it out. Maybe there's some other better, faster backup method to use. And the truth is that not always you have any chance, option to pick from. Therefore, there is another way of implementing quick recovery. In some scenarios at least. So another way of ensuring availability is to have some sort of standby environment on a separate location. This could be a full-blown environment, like virtually a mirror of your production setup on the different data center, East Coast, West Coast, Ireland, Frankfurt, whatever. But obviously that will be pretty expensive to maintain it. Or it could be a very small stub, like a couple of hosts maybe, or even single host located on the other in different location, which will allow you then to build everything from scratch. For example, what you can do is basically use a second backup server located in a separate data center. You can either use it just directly to provision your hosts. You can also use backups that it created to provision your host if needed. So it will speed up the provisioning process should you need to actually build the scale, this staging, this temporary, this standby environment into full size. And on the right, you can see you have a screenshot from the cluster control, the deployment wizard, in which you can easily deploy a multi-master active standby type of replication. And of course, the standby master can be created in a separate data center if you like. Of course, unless the connectivity is required, but that's pretty obvious. So again, backups are essential because any kind of standby environment may not be enough to save you from drop schema production. Even delayed slave may not always be enough to handle this kind of problem. Maybe not drop schema production, because it would be pretty noticeable, I would say, but deleting some part of pretty important data which is not detected before the delayed slave actually applies this change also. So backups are essential anyway, and you have to have them, and you have to have them distributed to anyway. What is very also important that you have some sort of runbook recovery process. I'm talking here about step-by-step simple instructions like copy paste even, because if things are really if you're under fire and if things really went crazy, then people under pressure will make the mistakes, and like this such simple copy paste type of runbook will help them to execute the process efficiently and without issues. Of course, you want to test the recovery process on a regular basis because you want to be 100% sure that it works. Yes, that's pretty important. You don't want to some weird change that was introduced by someone at some point to break things and make your polished runbook not really working. That would be a disaster in case of a disaster. So just test the recovery process, perform switchovers, verify that it really works for you, and and this. And you should be relatively safe when it comes to handle serious problems when it will come. So if you are interested in more content related to MySQL replication, then feel free to take a look at our blog section. I put here a couple of links to different material. But we have a white paper, we have a couple of blogs correlating the MySQL replication. And if you're interested in cluster control, also there is a getting started page on 7nines.com, so you can download it and test and see if it fits your, if it fits your needs and if you like the product. And now, before we go to questions, I will hand over to JJ for the last poll of the day.
Yes, thank you, Christoph. And before we do this poll, just a reminder, if you have any questions on the content you've seen so far, feel free to ask them, still in the question section of your control panel. And we'll take a few minutes to answer them. But just for now, last questions from us to you, if that's okay. Just to ask what version of or versions of MySQL you're currently using yourselves, whether it's 5.5 or 10 MySQL MariaDB, and up to 5.7 for MySQL or MariaDB 10, or some older versions. That could be possible as well, of course. So it'd be great to get your feedback here. Thanks for your participation in this last poll. And if you have questions, like I said, feel free to ask them still in the question section of your control panel. We're almost on the time that we had allocated for this webinar, but we can take a couple of minutes more to answer these questions, of course. But for now, thanks for your participation here, and I'll just close the poll now and share the results. Right, so it looks like the majority of you are on MySQL 5.5 or MariaDB 10, but also nice to see a good few of you on 5.7 and 5.6. So It's nice to see people using the latest versions, MariaDB 10 as well, 10.1. That's good to see. Thank you for your feedback there. Christoph, any thoughts on those numbers here?
Yeah, well, definitely what I would like to kind of mention that for those of you who are running the older MySQL versions like MySQL MariaDB 5.5 or MariaDB 10.0, I would suggest to take a look at different upgrade opportunities. It's not because all those versions are bad or something, but the thing is that when talking about MySQL replication, GTID and multi-threaded replication, it's especially true for MySQL and Percona servers 5.5. That's basically there are plenty of goodies in the new versions. So yeah, I would just really strongly recommend to take a look at the newer versions of MySQL to see if they fit your needs, and yeah, it's just more nice things to use and makes things much easier to administrate. Like as I said, GTIDs, multi-threaded replication, allows better scale up, allows more, for better flexibility. So yeah, that's I guess that's all.
Thanks, Christoph, and thanks for everyone's participation in this poll. Let's look at some of the questions that are being asked. Right. So there's a question from Nick here on in your experience, Christoph, and so what are your recommendations basically on the right way to monitor MySQL replication health or the health of your MySQL replication setup? Any recommendations on how to monitor that specifically?
Mm-hmm. Yes. So regarding replication, what the most important metric to monitor is definitely MySQL lag, replication lag. It doesn't mean that you can always do something about it, because sometimes it's just inevitable. But you want to track this. And also you want to track the health of SQL and IO threads for the replication to see that to ensure that they are working correctly and there's no error and the replication is actually running. If you're running multi-threaded replication, you can also try to check. You want to check the state of every single thread. This is available through performance schema. I don't recall exactly the query to get this, but there is information about multi-threaded replication. So which thread is applying which event. This also can give you some information about what sort of parallelization you can actually achieve using MySQL replication.
Thanks a lot, Christoph. And I just sent a message in the chat to everyone here. I hope you can see it. Just because we were talking about upgrading to MySQL 5.7, we do have a white paper on that, so feel free to download that. And it has a lot of good insight and a lot of data on how to proceed with such an upgrade. So I just want to share that with everyone. And there is a question here from Mark, Christoph, on whether MySQL 5.6 is the minimum version to be on for GTID. Is that correct, or do we need to be on 5.7?
Yes, so for the GTID, that 5.6 is the minimum version when we're talking about Oracle or Percona server. I believe for MariaDB, if I remember correctly, it's 10.0 when is where the GTID was introduced in MariaDB.
Great, thank you. And let me see. There's another question here from Mark, but it's rather quite long. so I don't know if you can read it, Christoph. That's okay,
Yeah,
Mark. It's just long to read. It's long to read out. Sorry, that's what I meant. It's not a long question. It's just a long to read out for everyone to understand easily. But can you shorten the question, maybe, Christoph, and answer it? Is that possible, or should we answer it by email?
yeah. So basically, the mark is asking, that for about the performance of my loader. So about I mentioned that 1 terabyte data can be dumped in like for 6 hours, and what's about the restore time? I don't have the exact number. How long will it take? I don't recall exactly for this particular customer. It was faster than MySQL dump. It was not like 2 times faster. I believe it was more like 1.5. But I mean, it's still like from 2 days to 1 and something. It's still better than nothing. So it's not like as fast as physical backup. No way for that. But still better.
Okay, great. Thanks a lot, and thanks for those questions, of course, and thanks for the answers, Christoph. We're a bit so we're over the timeline we had allocated for the webinar, but it was great to go through these questions. If there are any more questions, follow-up questions, feel free to send them to me at jj@7nines.com, and we'll continue, of course, the conversation there. But I think for now we've reached the end of this webinar. Thanks everyone for your participation, and thanks, Christoph, for the presentation. This was our last webinar for this year, but we're planning, of course, new ones for 2017. So we'll be sending out invitations, of course, for January or early February. So look out for that. But for now, have a good rest of the day and a great week, and we'll be in touch with the replay details of this webinar. So we'll post them online probably tomorrow or the day after, so you'll have access to the slides and the recording of this webinar as well. But thanks, Christoph. Thanks, everyone, and talk to you soon. Take care. Bye-bye.